So complex numbers. So we've already looked at definition. Okay, we've already looked at definition where we say that a complex number represented by z is equal to is a number in the form a plus bi. Okay, where we have what is called the real part. The real part of a complex number z, in this case, is a, and then the imaginary part of this complex number z is equal to what? Is equal to b. Okay, so the part with I is the is the imaginary part. Now we defined I. Okay, I is equal to, so we say where I is equal to root of negative what? Negative 1. Okay, so I there is simply representing negative 1. Then we also looked at this can also be written as z is equal to what? X plus yi. So it's just a matter of representation. Whichever letter you want to use, you can use them. But most commonly we use a, b, or x, y. Okay. Then other than that, we also looked at what is called the Argand diagram. Okay, so the Argand diagram, this is simply it's simply what the graphical. Okay, the graphical representation of a complex number. Okay, now this set of complex numbers is the largest set of what of numbers, because this part is the real these are real numbers. Okay, so in other words, this the a there is a member of what? A member of real numbers. Okay, it's a real number. Even this b is also a real number. Okay, so the b is a real number and the a is a real number. But on the part of b, we also add the I, which is making it a complex number. Okay, so if you remember if you remember all the sets of numbers, you said that natural numbers are a subset of what? Whole numbers, which are a subset of integers, which are a subset of what? Subset of rational numbers, which are a subset of what? Real numbers. Okay. Then from there we say that this is now a subset of complex numbers represented by the letter C. Okay, and so on. So in other words, all these sets of numbers that we've been talking about, they go into the set of what? Complex numbers. Okay, so the Argand diagram is the graphical representation of complex numbers, and we use the xy plane in the x-axis. The x-axis, okay, the x-axis is the one where you're going to have what? The real part. Okay, the real part of the complex number. Okay, that's why you have the real part, and then the y-axis. In the y-axis, that's where you have what? The imaginary part. Okay, that's why you have the imaginary part of the complex number z. Okay, so if we have you have a and b like that, where you're having the complex number z is equal to a plus bi. Then if you plot the point AB, let's say you plot it there, it's going to be a comma b. So the complex number is going to be this one. You join the origin to the point a comma b. So this one is going to be z is equal to a plus bi. Okay, and then from there we moved on to look at what is called the magnitude of a complex number. Okay, so magnitude of a complex number, here we just use what? We just use Pythagoras theorem. So this part, this side, this is the b, then from there to there, that is in a. All right, so magnitude of a complex number z is simply equal to the root of what? A squared plus b squared. That's all. Okay, so that's how you get the magnitude of a complex number. And then you also look at what is called the argument. The argument, okay, which is theta. Or rather, if you connect these two vectors, in other words, you're just trying to look at the direction of the vector. So we say that theta is equal to tan inverse, okay, b over a. Okay, or if you are using x, you can say theta is equal to tan inverse of y over over x. Okay, all the same. So that is basically what we looked at, and then from there we moved on to look at addition and subtraction. So I'm trying to go through quickly what we did, because I don't think I recorded those videos. Uh, I'm trying to go through very quickly what we did, what we've done already. Okay, so we moved on to look at addition and subtraction of complex numbers, right? So now we said that given that, let's say the first complex number z1 is equal to a1 plus b1I, and the second complex number is equal to a2 plus b2I. Okay, then what we say is that a plus, z1 plus z2 is going to be equal to, what? A1 plus b1I, then plus what? A2 plus what? B2I. Okay. So eventually, if we're to collect the like terms, the real parts and the real parts together, the imaginary parts and the imaginary parts together, we're going to have A1 plus A2, okay, then plus B1 plus B2I. Okay, that's what we're going to have. So this is what we are going to get when we add that complex number. So we already looked at that. And then subtraction, how do we subtract? So I'm going to be a bit more careful on subtraction. So we say that z1 minus z2 is going to be equal to a1 plus b1I minus what? A2 plus B2I. Okay, so if we distribute the negative throughout, they are going to have A1 plus B1I minus A2 minus B2I. Okay, so this is eventually going to give us the real parts together, the imaginary parts together. This is going to be A1 minus A2, then plus B1I minus B2I. Okay, then what are we going to get? Here we can factorize the I there. We're going to get, this is going to be A1 minus A2, then plus B1 minus B2I. Okay, so that is what is going to give us, that is the complex number that we are going to get when we add, we subtract those two complex numbers. Okay, right. So let's get back to today's lesson so that we go through it quickly. It's not something that is very complicated. Okay, so I want you to follow me very well. So we look at multiplication of complex numbers. So multiplication of complex numbers. So we said that given that z1 is equal to let's say x1 plus y1I, and z2 is equal to, let's say, x2 plus y2I. Okay, then what are we going to have? We say that z1 multiplied by z2 is going to give us x1 plus plus y1I multiplied by what? X2 plus y2I. Okay, so we start expanding there. We now expand. Okay, x1 by x2, that is going to give us x1 x2. Okay, then x1 by y2I, that is going to give us plus x1 y2I. Then y1I multiplied by x2I, this is going to be plus x2 y1I. Okay, then y1I by y2I, this is going to give us y1, y2, okay, then I squared, right? I squared. Okay. Now I want you to get this. Okay, so we've expanded there. We have done the expansion. Then we say, but remember, I is equal to root of what? Root of -1, isn't it? So therefore, I squared is equal to root of -1 squared, isn't it? Okay. If I is equal to root of -1, then it means that I squared is equal to root of -1 squared. So the root and the square and the square root, I mean the square and the square root, they're going to cancel each other. So we remain with what? -1. So in other words, -1 squared, I squared is simply equal to -1. Okay, it's simply equal to -1. So it means that where we have I squared, we're going to bring what? We're going to bring -1. Okay, we're going to put -1 there. So let's go ahead and replace that part. So what we're going to have is, so therefore Z1, Z2 is equal to X1, X2 plus X1, Y2, I, all right, and then plus X2, Y1, I, okay, then plus y1, y2 multiplied by -1. Now you can see that the negative there and the positive can multiply so that we have a minus there. So this is going to be x1, x2 plus x1, y2, I plus x2, x2, y1, I minus y1, y2. So then we can collect the real parts together and the imaginary parts together. So this is going to give us what? We're going to have x1, x2 minus y1, y2, then plus x1, y2i plus x2, y1, I. Okay, so you can see on this part we have a common factor there, which is I. Okay, the I is common there, so we can factorize the I. So then what are we going to get? This is going to give us x1, x2 minus y1, y2, all right, and then plus x1, y2 plus x2, y1, I. Okay, so this is going to be the product that we're going to get. Okay, that's the product that we'll get. Now let's look at an example very quickly. So multiplication of complex numbers is very simple. So let's look at an example. Okay, an example. We say that given that Z1 is equal to, let's say, 2 minus 3i, and Z2 is equal to 1 minus 4i. Okay, find Z1, Z2. Okay, so we have to multiply those two complex numbers. So solution. Okay, so we are saying that Z1, Z2 is equal to, it's going to give us what? 2 minus, oh my god, okay, so Z1, Z2 is equal to 2 minus 3i, okay, multiplied by what? 1 minus 4i, right? 1 minus 4i. So what are we eventually going to get? So we start expanding as usual, okay? We start expanding. So 2 by 1, that is 2. Then 2 by -4i, that is negative 8i, then negative 3i by 1, that is negative 3i, okay, and then negative 3i by negative 4i, that is going to give us what? Plus 12i squared. Okay, plus 12i squared. Now we already know that I squared is simply minus 1. Okay, it's simply negative 1. So what are we going to get? That means that this is going to give us, so this is going to become negative because I squared is negative 1. So negative 1 by a positive there is going to be negative. So this is going to be 2 minus, so negative 8 minus, minus what? Minus 3i, negative 8i minus 3i, that is negative what? 11i. Okay, then here minus what? 12. So this is then going to be 2 minus 12, that is going to be what? If we collect the like terms, that is going to be negative 10 minus 11i. So that is going to be the product of the two complex numbers. Okay, so complex numbers are as simple as that. So we are remaining with addition. I mean, remain with division of complex numbers. But before looking at division of complex numbers, we have to look at what is called a conjugate. Conjugate of a complex number, right? Conjugate